And all right, welcome to the well, not the first, but the current eduGAIN key ceremony. So today we're going to generate a couple of long-term credentials that eduGAIN will use for well, a few years, hopefully. The purpose of the exercise is to produce a couple of, well, one RSA key with 4K key length and an Edwards curve, elliptic curve key that we hope will be maybe a future asset for signing content in eduGAIN, but we're not going to start using it perhaps this minute. Well, we should do a round the table introduction just to say who we are, even though you probably recognize at least some of us. We've invited like anybody in the office who wanted to come along and sit in on it. So I'm a few of my colleagues. We have, well, I guess we'll start with Björn, who's at the console today.
Yeah, Björn Mattsson. We're running the keyboard for typing all the commands. I'm working at SUNET, mainly with the Federation, SVAMID, and other federations we run.
Yeah, Checksum, also in SUNET working with SVAMID and here is to observe and check that everything okay and check the printer paper.
Right, and I'm Leif Johansson, and I'll explain the whole setup in a minute, so you will all understand why there is a printer in the room and why there is an old printer in the room. With me, I have one of my colleagues.
Yeah, I'm Kushal Das. I'm a Python code developer working for SUNET, mostly looking at security and privacy, and I'm just witnessing the thing in real life.
Hey everyone, I'm Nicole Harris, Head of Trust and Identity Operations at GÉANT and part of the eduGAIN Secretariat. I'm going to be helping supervise here to keep all the boys in order, and also going to be responsible for storing some of our key material. So I have a bit of a journey ahead of me after this, back to the Netherlands first.
Hello everyone, this is Davide Raghetti from GAR. I'm also the eduGAIN service owner, and today I will play the role of plugin, basically the USB sticks and the UB keys in the machine, the key generator, and I will also bring back some of these USB sticks to the GAR headquarters in Rome.
All right, so let me start by standing up and pointing you at some of the stuff we're playing with here. Now, I'm hoping that you who are at home looking in on Zoom can see the screen share that's sort of running off of our console. But I also hope you can sort of switch to gallery view and look at the video feed right now, because I'm going to point you at our setup so you understand what's going on here. In fact, Nicole, if you could join us via your mobile, and we may get a second video feed here that will also show everything. Now, before, I think, well, at least one or two of you might be wondering, sort of, there are lots of laptops and there are lots of computers and there are lots of mobile phones in the room. And that is there is a sort of a natural balance to strike between transparency and sort of technical protection. And we've opted for transparency today. We are definitely sort of banking on the fact that we have sort of enough transparency to be able to prove and to be able to verify the quality of the key they're producing. And in a different situation, might have made different sort of struck a different balance, but today this is what we're doing. So panning around the room a little bit, let's start over in that corner. Looking at the table right now, we have the little, I don't know, an red-orange box with a couple of orange UB keys on top. That is the box where we're going to run the key generation on. Now, that machine has never been connected to a network, and it's been sort of fresh installed with a stripped down version of Linux. And the only purpose of that machine is to talk to this piece of equipment. That's a random number generator that was built as part of the Cryptech project that some of you may know, have heard about. It's a very good entropy source, and we're going to connect that to the machine, and we're going to use that together with OpenSSL to generate our keys today. Now the keys, they will be protected in PKCS12 format with a password, a static password, and that password will be put on those, installed on those YubiKeys that Nicole is pointing to. We're going to have those, the orange YubiKeys, those will be sort of configured in static password mode. And one of them will go with sort of each of the key bearers. It will go to different locations. And the idea is that the key material in encrypted form goes on the USB sticks. The password that protects them goes on the YubiKeys, and nothing stays on the box. However, to be absolutely sure, that machine will not be recycled or used for anything else. It will be deposited in one of these tamper-proof bags we have. So the key material, the USB sticks, the YubiKeys will all go in bags like this. They are standard tamper seal protected bags with serial numbers on them, and we're going to stick the serial numbers that are right there, and we're going to take pictures of them as we go, and the serial numbers will be added to the log of the session. That gets us to the exciting part of having a printer, an old dot matrix printer in the room. So the setup here is that console cable from the machine is coming into a splitter like this. This splitter goes to Björn's laptop and to a printer. And the effect of that is that everything that goes in and out of the console software on Björn's machine, anything you see on the screen share, also goes on a hard copy into on the printer. And the splitter here is a really dumb device. There are no computing devices in the splitter, just a couple of diodes that enables us to have a very high degree of confidence that whatever comes out of the machine actually is the thing that Björn sees on his laptop and you see on the Zoom share, and whatever Björn types in is actually the thing that winds up on the machine. So we're going to take the output of that, the old tractor paper that we actually found on Office Depot in Stockholm the other day. There were three boxes in all of Stockholm. So this is a legacy take, obviously. And we're going to take that, and we're going to initial all the pages after we're done, and we're going to stick it in a log, so we can review it afterwards, and also so we can be sure that the fingerprints that we generate, etc., is the same thing that we publish on the web. So the idea of this exercise is to produce a key, generate the self-signed certificate, and then when we're done with that, we're going to make a little pause in the recording. We're going to take everything into our data center, where we're going to import the key that we generated into the HSM platform that we are going to use for eduGAIN in the future, or in, well, not too distant future, relatively soon. And we're going to, after we're done with that, all of the key material, all of the machines that we use will go into tamper bags, and that will be the end of the key ceremony. So we hope that this will go smoothly. It probably won't. You know, this is sort of the nature of things when we do some stuff like this, that there will be hiccups. And when that happens, I will sort of just raise my arm and say, all right, we've got a technical problem. We're going to pause right now to sort of resolve it or whatever. And then we're going to go on. And with that, I think we're going to get started. Now, the starting point here that we are at is that the machine has been booted. As you can see, we have a login prompt running. And when we do stuff, you're going to hear the printer sort of echoing what we do. So there is a little bit of noise in the room, but All right.
Did you speak? Were you-
The-
I don't know when it has been.
No.
I think everyone heard it fine.
All
I
right,
think maybe
yeah.
it just muted when they stopped
Yeah,
talking
no,
for
no.
some reason.
Okay.
So Niels has a question. Do you guys have a playbook of the stuff gathered and the procedure you'll be following that might help others and add transparency?
So we're going to talk everybody through it as we do it, and we're going to publish the playbook afterwards. But we haven't pre-published it. Okay, so something muted in the last 30 seconds. I don't know why, but I didn't say anything important in the last 30 seconds. So I think my point was to say that it will be a little bit noisy because of the printer echoing stuff. So.
And Thomas has just pointed out that the clock is wrong. So.
Well, the clock is actually not moving. So it's just there for sure.
It's correct twice a day.
It's correct twice a day, exactly. All right, I think we get started.
Start by checking the clock, and it should be correct according to my logs.
It is.
Yep.
So Martin has a question.
Yes.
Should you take it?
Can someone tell something about how the backups will be arranged?
Well, we're going to create. We're going to store 2 copies, and of the same key, and the YubiKeys will be configured with the same static password. So, in fact, the YubiKeys are actually equivalent. We're not running the M/N scheme here, so we are going to make an effort here to make sure that the YubiKeys and the USB keys are actually kept separate. So the sort of two separation of control here is implemented by having like the encrypted key in one place and the YubiKey in another. And of course, the next time somebody unpacks this, what we strongly suggest we do at that point is to go look at the serial numbers of the bags that we record in the logs today and make sure that those are the same serial numbers that are actually being pulled out of various safes around Europe. All right.
Yes.
I hope that answers questions. But if anybody has questions during the proceedings, just sort of feel free to type them into the chat, and we'll try to answer them. All right. Now, the first thing we're doing here, and I'm going to have to go up because I am sort of standing too far to actually read off and comment on the proceedings. Björn is sort of starting the work and setting up this environment for key generation. And the program get code here is a small Python code that Björn wrote to read YubiKey keyboard output. And the reason for that is, of course, is that we're talking to the console port here on the machine and not to a regular USB keyboard. So we actually have to do a little bit of coding to extract the one-time or the password from the YubiKey. But please go on, and I don't think you should just pause too much for me. I'll tell you when you need to pause.
Okay. Plug the USB in, and we'll start the entropy source.
Right.
Okay. We plugged the random generator
right now, and I can see that the random number generator is blinking, indicating that it's starting up. And we've started the RNGD daemon on the machine.
It's up right. We check the source.
Right. Of course, Björn is not typing that fast. He has a playbook in a notepad, and that playbook is something we will, of course, publish. Now, what we're doing right now is we're grabbing a lot of data off of the entropy source and running a program called GÉANT, which is a way to test. It's very, very simple way to do smoke testing on an entropy source. And right now, we're getting 7.999 bytes of entropy per byte, which is a very strong indication that the entropy source is working, doing exactly what it's supposed to be doing. All right, what we did now is Björn generated a 16 byte hex string that is going to be the secret encryption key for the keys. And as you can see, we're working on dev.hsm, so that's shared memory disk on the machine, which means that nothing we do will be kept sort of on any kind of permanent storage on the machine. Nevertheless, we're still sort of we're still gonna put the machine in a tamper bag afterwards, so it's not going to be reused for anything.
Okay, plug the first YubiKey in.
So now what we're going to do is to
Take up a
code
problem.
the YubiKeys with the shared password we're going to use to encrypt the key.
You got to press it.
The first YubiKey has gone in.
Yeah.
And we're going to program it.
First key is programmed. Switch.
All right.
Okay.
That's the first key. Now, after this step in the procedure, we will have two YubiKeys with exactly the same password. Now, right now, that password is available on a file on shared mem, but as soon as we turn off power to the machine, it will be gone.
I think we should take a break and switch the cables, because you're going to push that button a lot of times.
Okay.
Right.
And we will start the random generator afterwards.
Okay. So is the YubiKey programmed?
Yeah.
And the reason we're doing this is because it's kind of physically tight space between the two USB ports. It's kind of hard to get at it. So we did a restart of the random number generator at this point. So now, all right, so we have to
Again?
restart it again.
We have to change it since we should switch. Yes.
USB.
Yeah.
Get rid of that.
Cool.
All right.
There, stop.
So there's the right one.
All right. So what we did now was to switch the USB ports under RNDD, and this just for practical purposes, because we didn't want we wanted the USB keys to be actually on top, so we can actually physically access it. When we do this in 10 years, we'll remember to do that.
Yeah.
Or 20. Anyway, so what we've done now is to remove the file where we stored the password. So the only place we have that password now are on those two YubiKeys.
Could plug one YubiKey in.
All right. So at this point, we're going to generate the RSA key and the self-signed certificate. So before now we're generating the 4K.
Yeah, and it's waiting for input. So
yeah, right. So by pressing that key, we're feeding the password into OpenSSL to encrypt the key. So now we should have a PKCS with 8 RSA key, 4K length. This is going to be the private key for eduGAIN. Now we're going to have to press that YubiKey again. Now we are running OpenSSL to generate the self-signed certificate. And now we're doing third step. So the first step was generating the certificate request, and now we did the self-signed certificate. And at this point, we're generating an Edwards curve key. So we're doing the same process again with to create an elliptic curve key instead of just an RSA key. Right. So at this point, we have two sets of key pairs. We have an RSA private key and an Edwards curve private key and the corresponding certificates. And here we see the fingerprints, the SHA-256 fingerprints of the RSA key.
And we compare the certificate with key.
Yeah, and they should have the same fingerprint.
Yeah.
And as we can see, we've generated what seems to be a key pair with this fingerprint. So if you all want to, let's
This is not the fingerprint of
the search. No, no, it's the fingerprint of the privacy. So something. That's the property of the.
Press again.
Niels asked, should you test with the other UB key as well?
Yeah,
We can do that.
we can switch.
Let's switch to the keys. That's a good point, Niels.
Okay, so let's switch new keys. And let's do the test.
Run the same command again.
This is the elliptic one.
Yeah.
We have to do the RSA. Oh.
We have compared that the same. We can run with the.
Yeah.
And it's exactly the same.
Just to verify that the sheets are encrypted.
All right.
And
So while the printer is churning out pen, I think if you all took a picture of your screen at this point, that is the new eduGAIN, the PEM of the new eduGAIN signing certificate. So I think it would be great if when we publish this, everybody who's been online today, go back and look at the whatever we publish and make sure that this is in fact what we publish. That is kind of the tie to the key ceremony. We have we've chosen 20 years validity for RSA sort of as a reasonable compromise. I mean, we've seen nothing to indicate that there's sort of an imminent threat to long RSA keys. But if something like that should appear tomorrow, then I think we're going to have to revoke eduGAIN and restart everything anyway, right? And there's really no reason to sort of to choose a short-term key, and we are purposely using a very, very long key length here just to sort of hopefully be able to keep this for a while. But there are no guarantees in this world, so we'll see.
that shows information.
Public certificate for the elliptic.
Yeah, we're going to do that.
Mm.
And here are the info for.
So this is the circle of the elliptic curve. Yeah. Now again, I don't think there is a plan to start using the elliptic curve signatures right now for eduGAIN, but it's something we're keeping as a sort of I guess as a piece of insurance.
Yeah.
And the same information for. Okay. And now we finish.
All right.
So they have all info.
All right. I think that sort of concludes the part up here. Now
Now we're going to move it.
yes, at this point we're gonna take a little bit of a break. So we're gonna reconnect to
Now
this room.
we're going to move to USB stick before.
Yeah.
we break.
Right,
Yeah.
exactly. We're gonna move, right, exactly. We're gonna copy the encrypted keys and certificates to a USB stick, to regular sort of USB stick. And then we're gonna, well, pause the recording and then move downstairs.
We have four, yeah, now have 4 different files that are going to be moved.
Okay.
So we're starting by making a checksum.
These are sealed.
Thomas is asking, would this be the right moment to send the certificate to the OT? Thomas isn't patient to get cert.
Yes, as soon as, well, as you know, Thomas, we don't actually have a network connection from this machine, right? So the only way to get this cert out is to grab it through the USB stick.
Yeah.
So
You can unplug both of them. You can unplug both cables.
Yeah.
yeah, there are the random number generator has served its purpose now, so we're going to disconnect that.
Okay, USB stick in.
Yeah. We start by yes. We mount it up. Copying it over. And verify that it's the same material that we
Yes.
copied.
And of course, the key here is an encrypted key, and you can't actually use it unless you have access to one of those YubiKeys.
Okay.
Great. So this is stick 1. We have to put this one in the sealed bag right now.
We can put it there.
Yes.
With
Yeah.
the YubiKey.
I just put it over there.
Yeah, and then we will seal it. Second one. This one is a bit more tough.
No pressure.
Yeah.
Now, if you're keeping track of the proceedings, you notice that we put the YubiKey and the USB stick in the same serial bag, and that is the intention here is that we are of course going to record the serial number on that
Okay.
tamper bag, and so that is kind of our protection against sort of somebody inadvertently or advertently opening the bag in transit. So we're going to verify that.
Check some more.
Okay, checksum that we have right here.
Yeah. Definitely.
Then you can unmount. You can unplug it.
Yeah. And oops.
Now, if you turn those over, Nicole, you can take a couple of videos and also take a couple of pictures of the serial numbers,
The third.
and both sort of share the serial numbers into the recording, and also photograph them and send them to the OT list. I think it is there's one serial number, and there's another serial number. So there is documentation of that in the recording, and
our photos too, yeah.
yeah.
Okay. So now for the certificate.
Yes.
And we're
Oh.
gonna,
We have a tenant meeting.
Tenant wants us to read the serial numbers out.
very good.
Okay, so bag number 1 is 260027652431.
And I can seal them. Yep.
And bag 2 is 260027652428. Was that clear enough over the printer?
sealed.
Let's see.
It's on the printer.
Cool. So now I will also make this one. Maybe this time. Or scissors, whatever.
This is my favorite part, watching you try to interviews.
Unboxing.
You wouldn't be a YouTuber.
Yes. Okay, and now for the certificate.
And the certificates are the same on that USB stick.
Great.
And then just to be sure, empty is empty. So nothing has been copied by mistake.
All right, so I think that means that we have 2 bags with the actual key material and certs, and 2 USB sticks with the publication material. All right, at this point, I think we're going to take a little bit of break because we're going to get set up in our data center downstairs for importing this into the HSM platform. I think maybe just pick a time, let people get some coffee and take a technical break. So 11.
I'm looking at that clock, I don't know why.
That clock is just there.
Past 5.
That clock is just there to annoy you.
5 past half.
Right.
And we're also sending the public certificate to Tomasz
Yes.
for publishing on the technical site.
Yeah, exactly. And we're going to do that in the break. But let's reconvene on the Zoom in the Zoom channel at 11. I mean, we're going to keep a connection open, but this room will actually be empty because we're going to be elsewhere with video cameras or with our mobiles. All right.
Great.
All right. See you in a bit.
Can I
All right, folks. I don't know how many of you are here with us. I see about 30 participants. A lot of you are muted still. And we're back at, we're going to be starting up in about 3 minutes. And we're going to be running sort of the last part of the eduGAIN ceremony. And there's a bit of background noise here because we're actually in the middle of an office environment here. Now, in order to make this sort of reasonable for you, we've created a setup that's just outside of the data center here at the SUNET offices in Stockholm, and we have a long Ethernet cable running from the machine where we just sort of did our key ceremony out to into the data center where our HSM is connected. So I'm going to see if I can get. I don't think my camera is working, right? Am I?
You're not filming me.
I'm filming you. All right. All right. For some reason, Zoom on my phone isn't giving me feedback from my camera. So I'll just hope that this makes sense. But anyway, here's the setup with the machine that you possibly recognize and where we just did the key ceremony. Of course, that machine has now been powered off and carried downstairs to the data center floor at SUNET. And that means that everything that was on that machine is now gone. Except the operating system, of course. So we're gonna unseal one of the seal bags that we just sealed. And we're gonna reseal it with a new serial number in a bit. That's the serial, the one, right? And I can just film I do have to make sure that this actually looks good on because my phone isn't showing me any picture. All right, so that's the one of the bags that we just sealed, and we're gonna unseal in a bit. And the next serial number we're going to use is this, and it's 26027652403. So that's going to be the new serial number on the bag that actually gets sent down to, I think, Amsterdam. And the other one is going to wind up where? Rome. It's going to wind up in Rome. All right. So here's the setup. We have a long Ethernet cable running on that machine. And that Ethernet cable goes not into a switch or any network equipment. It goes directly into, I'm going to raise my voice a little bit, goes directly into the backside of one of the two HSMs. The HSMs are those two shorter looking machines sitting in one of our racks at the office. And you can see this cable going into one of the interfaces on that HSM. And the idea, of course, is that we don't want to connect that machine to the network. We don't want to connect our super sensitive key management machine to the network. We just want to connect it directly to the HSM. Now, right now, we're in the process of doing config on the key generation machine so that we can talk to the HSM, and that's being done right now. And in a couple of minutes, I think we're going to be ready to restart sort of the importing over here. And I'm going to pause my audio for a little bit until we are ready to resume in a few minutes. Well, what's happening right now is that one of the engineers at SUNET, I'm going to show his picture right now. Hello. That's Erik Bergroth. Bergström, also known as Barra. He's right now, what he's doing is working the keyboard here, making sure that the key generation machine can talk to the HSM. And when that is done, yes, I actually turned off my video because right now we're just sort of showing people typing at keyboards, and we can see that from the screen share just as well. And what's happening right now is that the guys are configuring access to the HSM from the key machine. And the command you saw there was VTL verify, which is sort of the HSM platform's way of saying, all right, we can talk to the eduGAIN token, and that's a virtual partition on the HSM cluster. We're actually just talking to one of the HSMs right now, physically, as you saw. And the idea is that we're going to import the key to that particular HSM, and then we're going to use the replication mechanisms of
I started now.
Yeah. All right. So we're
Putting this up and go into the directory.
all right now. Björn is right now getting ready. Now what I'm gonna start video again. And I'm showing Nicole unsealing that tamper bag. And yes, this is the point of a tamper bag, that it's evident that you have unsealed it. We have a USB key and a YubiKey key. Now the idea is to stick them both into now. Yeah, I suggest you put the USB in below, because it makes it mechanically easier to do things, and the YubiKey top. All right, and now we're gonna mount the drive, access the key material in encrypted form, decrypt it with the YubiKey, and then hopefully all right. All right. There we go. All right. I think you have to do clear the screen a little bit, because it's kind of messed up on the. This is one of those times that I told you about, that not everything is going to run smoothly. And all right. All right, Nicole is pressing the key. And now we've extracted the private key to shared memory. So we have the private key in clear text format in shared memory. And now we're gonna see if we can talk to the HSM to actually go ahead and import that. Now, we're gonna use a command called CMU, and that is part of the Luna client. You have to go to the directory. So it's user safe. User safe. Yeah. Now this part is always a little bit confusing to me when I play with this tool seldom, and the Luna client tools are one of the least well documented. Right. And what we're gonna do now is not film the. Be careful not to film the screen, because we're actually typing the PIN code of the Luna token into the command. command line tool at this point. And I'm going to hedge my bet and say that we're going to be running these commands a few times before we get it right, because that's usually. All right, we hit our first snag, I think. So apparently the Luna is not happy with the file that we want to import. I think that what we're doing here is that we're feeding it a binary, an ASCII, a PEM file, and we just have to use PKCS10 to convert it to a DER, to binary format. So we should use OpenSSL to do the file conversion. So I think we may need to stop sharing for a little bit, because we're trying to figure out what's going wrong with the file type here, and we don't want to accidentally leak the private key onto the stream. So we stop sharing for a little bit, and we're going to debug this and be back in a few seconds. All right, we're still not sharing, because now we're actually trying to make sure that the import actually works. All right, now we're going to start sharing again. So we figured out what the problem was. We were telling the Luna import tool that the file was a particular kind of encrypted file, which encrypted key file called PKCS8, which actually it wasn't. And now we're at the point where we've started the import tool, and it's asking us for parameters. Now at this point, we're going to use
They're not sharing the video.
No, I'm not sharing the video. That's intentional. I was just sort of trying to talk to the screen share at this point. So we also specify some private key attribute values, and because this is a signature key, CK decrypt should be false. Yes, and CK sign should be true because we actually want to be able to sign with this key. And unwrap should be false, and extractable should be false. Now that last parameter means that you can't actually extract this key from the HSM at this point, which means that if we should want to sort of change HSM platform, we actually have to go back to the key material stored in the tamper bags in the various safes in Rome and in Amsterdam. Now the next step here is for us to import the certificate that we created earlier during the key ceremony. Now we're hoping not to be too surprised by the various command line parameters of the Luna import tool, and at this point we are well, the idea of this command here is to import the certificate and to give it the label eduGAIN_RSA, which is what Thomas and Maya will use to configure their signing pipelines. This is kind of the name of the key in the HSM. All right, and then actually you might as well stay at the terminal. Next step is we're gonna run CMU list to look at the certificates we've created, or the keys present. Right. And if you're wondering about sort of the laughter in the background, it's because every time we do anything with the Luna, we're sort of switching people at the keyboard, and Eric is typing the password, which only he has access to as the Luna manager. All right.
Today, yes.
So, as expected, we have a few keys, and you can see that there's something called eduGAIN Prib and eduGAIN metadata sign. Those are the test keys that we've been using for a while. Now, the handle labeled 145 is the one that contains the production key that we just generated and imported, and handle 52 is the one that contains the certificate. And at this point, we're actually done. The next step here are more administrative in nature. We're going to set some parameters to make sure that the keys are extractable, but we actually already did that during the import procedure. So we are actually done for today. The next step here is for us to reseal the YubiKey and USB drive. So I'm going to start sharing my video again and show that happening. So I think if we unmount right, unmount, and let's just re-verify that that's the serial number we're going to use for the next bag, and let's just extract those. Yeah, we've unmounted the drives. Right, and here goes. Now, with a little luck, we're not going to see those things again for another 20 years. So in our lifetimes, probably. So you seal by sort of folding it like that, and you remove the little red tape. And right, there you go. That's a sealed bag, and that goes into a safe in Amsterdam. All right, and I think with that, we're pretty much done. So we're gonna initial the log, and the serial number. Niels is asking about the serial number on that bag. That is 260027652403, and the bag that goes in Rome is still 260027652428. All right, and I think with that, I think we wave goodbye to everybody. Any question? Any last questions? So Thomas is asking whether the key is published to all the HSMs. No, it is not. We're actually going to do a couple of synchronization procedures here, but it's kind of not really. Well, we could keep. I guess we could keep streaming when we work, but that would like having a Twitch account for eduGAIN, which we don't have. So I think this is a good place to end it unless there are more questions. So I think at this point, if there are any anyone who wants to sort of ask anything on camera or on video or on chat,